Our lesson today is to be able to find the mean for a set of data. The vocabulary words today are going to be mean, which is the sum of a set of data divided by the number of data items. The mean is also known as the average for a set of data. Our second vocabulary term is going to be outlier. It's a data item that's much greater or less than the other data items. An outlier may affect the mean. If an outlier is much greater than the other data items, it will increase the mean. If the outlier is much less than the other data items, it will decrease the mean. The mean summarizes a set of data using a single number. All right, well, let's start by calculating the mean. When we calculate the mean, we want to first find the sum of the data items, and then we divide by the number of items. So we start by finding the sum, so we're going to take 95, add 96, add 103, add 99, and add 96. So we start by finding the sum of that data, and let's see, 95 plus 96, 103 plus 99 plus 96. We get a sum of 489. We then have to divide by the number of data items. There's 1, 2, 3, 4, 5 data items. And we divide that by 5, and we wind up with, let's see, 489 divided by 5. We wind up with a mean temperature of 97.8 degrees. We first find the sum of the data items, and then we divide by the number of data items. Let's look at another example. You play a word game. Your scores are 12, 23, 13, 32, and 20. We want to find the mean score. So first we find the sum. All right? So we take 12, we add 23, add 13, add 32, and we get a sum of exactly 100. We want to then divide that by 1, 2, 3, 4, 5 scores, and 100 divided by 5 means we'd have a mean score of 20. Okay, let's take a look at some other examples. Your quiz scores in a science class are listed at the left. Find the mean test score with and without the outlier. What effect does the outlier have on the mean? All right. Well, what effect does the outlier Is this not recording? Okay. So we want to identify the outlier. So the outlier here looks like it would be the 42, because the 42 is significantly less than all of the other values. So let's find the sum without the outlier. So we want to take 81 and add 77 and 92 and 89 and 81 and 87 and 75 and 81. We start by finding that sum. 81 plus 77 plus 92 plus 89 plus 81 plus 87 plus 75 plus 81. We get a sum of 663. We want to divide that by the number of scores. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. So we divide that by 8 scores. And we wind up with 82.9. Right, for the mean. That's the mean without the outlier. if I want to find the mean with the outlier, I take that previous sum, 663, add the 42 to it. That's going to give us 5, 6, 4 is 10, carry the 1. That's going to be 705, but we're dividing that 705 now by 9. So let's see what that's going to give us. 5 by 9, that winds up with 78.3. So the mean with the outlier is 78.3. That's with our outlier. The mean without the outlier, all right, no outlier is the 82.9. So we see that the outlier, because it's lower than all of the other values, decreases the mean of the data. Okay, let's continue. All right, we want to find the mean without the outlier. So we want to try to do the same calculation again. First, let's identify the outlier. Well, I'm looking for a data item that is either significantly more or less than all of the other items. And I see the score of 28. Even though 28 is not a lot less than the other items, all of the other items, though, are between 37 and 42, so 28 is the only other number that's less significantly different than the other numbers. So let's identify our outlier as the 28. Then we want to find the mean with and without the outlier. So I like to do it first without the outlier. So that's going to be 40 plus the 37 plus the 39 plus the 40 plus the 42 plus 38 plus 38 plus 37 plus 40. Right? That's going to be the mean without the outlier. So let's add them together. 40 plus 37 plus 39 plus 40 plus 42 plus 38 plus 38 again plus 37 plus 40. That gives us a sum of 351. But we're dividing that by 2, 4, 6, 8, 9 scores. All right, so we divide that by 9, and that's going to give us a mean of exactly 39. So that's our mean without the outlier. That's no outlier. The mean with the outlier, I take my sum of 351, I add that outlier of 28, it's going to give me 973, and I get a total of 379 with the outlier. But with dividing that 379 by 10, that's going to give me 37.9 for the mean that's with the outlier. With outlier. So we'll see once again that because the outlier is less than all of the other data items, our mean with the outlier is going to be less than our mean without the outlier. And that should just make sense. Okay, let's take a look at this question. You keep track of the number of hours you babysit for 6 days. So you have 1¼ hours, 1½ hours, 1½ hours, 1¾ hours, 2 hours, and then 5½ hours. What effect does the outlier have on the mean? Well, first we identify the outlier, the score that is significantly greater or less than all of the other items, and we see that the outlier of 5½ is much greater than the other values. So what effect will the outlier have on the mean? It will increase the mean. Right? So you would just have to identify that it would increase the mean. Right? So we take a look at a couple of other problems like that. For each data set, identify the outlier, then describe how it affects the mean. We look at the weight in pounds of dogs at a kennel. I see that we have dogs that weigh 48, 50, 55, 60, 8 pounds, 37, and 50. Right? Obviously that 8 is going to be our outlier because it's significantly less than all of the other weights of dogs, and because it's less than the other weights, that outlier will decrease our mean. Alright, take a look at our next example. We have prices for flights from Miami, Florida to San Juan, Puerto Rico. The price of those flights are $456, $512, $516, $900, $436, $516. We see that we have one item that is significantly greater than all of the other items, so that will of course increase our mean. Alright, so we continue. Now we want to be able to calculate the mean from looking at different displays of data. Here we have a dot plot, and we're asked to find the mean temperature. Well, if I'm using the dot plot, I always like to list my temperatures, usually from least to greatest. So I have two temperatures of 45. Then I have a temperature of 47, temperature of 49, a temperature of 50, and a temperature of 52. Now we need to find the mean of those temperatures. So I have to first find the sum of those 6 temperatures. All right, so we start with 45, add 45, plus 47, plus 49, plus 50, plus 52. We get a sum of 288. The sum is 288, but we're dividing that by 6 to find the mean because there are 6 temperatures, and we get a mean temperature of 48. Alright, mean is going to be 48. Alright, let's take a look at another display of data. Alright, we have another dot plot. We're asked to find the mean. This dot plot shows the number of runs a baseball team had for each game of a 4-game series. Find the mean number of runs for the series. We're asked to find the sum of the data. So we take 1, so we have 1 plus 3 is 4, plus 4 is 8, plus 4 is 12. So we have a total of 12 runs for the sum of the data. There's 4 data items. So the mean is going to be 12 divided by the 4. All right, 12 divided by the 4, which would be a mean of 3. All right, so the mean number of runs for the series would be 3 runs a game. All right, another example. This dot plot shows the number of books Deanna read each week of a reading challenge. Find the mean number of books. Well, there were 1, 2, 3, 4, 5, 6 weeks, right, of the reading challenge. Week number 1, she read 1 book. Week number 2, she didn't read any books. Week number 3, she read 3 books. All right, so she read 1 book, plus 2 books, plus 3 books, plus 4 books, plus 5 books. She's read a total of 6. What is that? Let's see. Yeah, she's read a total of 6 books. So we have 6 books over a total of 1, 2, 3, 4, 5, 6 weeks. 6 books over 6 weeks means we'd have a mean of 1 book, right? 1 book for each week. All right, let's take a look at another example. All right, now we want to compare means. We're given 2 bar graphs, so another display of data. And the question says the double bar graph shows the monthly rainfall amounts for 2 cities over a 6-month period. Compare the mean monthly rainfall amounts. So let's start by identifying each city. So we'll start with city 1. So if I do city 1 over here, city 1, we need the average rainfall amount. So we have 3.5 plus 2.2 plus 1.9 plus 2.1 plus 2.5 plus 3.4, and I want to find the sum of those, let's see, 1, 2, 3, 4, 5, 6 amounts. So we have 3.5 plus 2.2 plus 1.9 plus 2.1 plus 2.5 plus 3.4. We get a sum of 15.6. But then we want to divide that by 6 because there are 6 different months. That's going to give us an average rainfall of 2.6, and these are what? Inches. So an average rainfall of 2.6 inches per month. That's city 1. City 2, all right, we'll do down here. City 2, we start with 1.7 plus 1.6 plus 2.2 plus, let's see, scroll it down a little bit. After 2.2, we have 2.1 plus 2.7 plus 1.7. So we want to find that sum. Let's see, 1.7 plus 1.6 plus 2.2 plus 2.1 plus 2.7 plus 1.7. We get a sum of 12 this time. We divide that 12 by the 6 months again, and we get 2 inches. Anytime you're asked to compare in a math class, I always tell my students, you must answer the question using greater than, less than, or equal to. So we would say City 1, right? City 1 has a greater rainfall than City 2, right? Greater average rainfall than City 2. All right, next question. Another display of data, this time a pictograph. It says find the mean number of representatives for each of the 4 states shown in the pictograph. Well, each one of these pictures represents a representative to the U.S. Congress for that state. So Tennessee has 1, 2, 3, 4, 5, 6, 7, 8, 9 representatives for Tennessee. Kentucky has 1, 2, 3, 4, 5, 6 representatives for Kentucky. Looks like Virginia has, if that's 9, this is 11 for Virginia, and then we have 6 for Louisiana. We find the total, right? 9 plus 11 is 20, plus 12. We get a total of 32 representatives for the 4 states. That's going to give us a mean of 8. All right, we take the total, divide by the number of states. We get a mean of 8 there. All right. Let's try another example. It says the table shows the number of CDs a group of friends bought. Find the mean number of CDs the group bought. Well, we have 3 plus 4 plus 6 plus 0 plus 2. So we have a total of 10 plus 5. Right? So we have a total of 15, but we're dividing that by the 5. Right? So we have 15 divided by 5 means that the mean is going to be 3. All right. Now, our last group of problems, we want to be able to, we're given the actual mean, right? We're told the mean is 17, and we're given some of the items, 21, or no, actually we're given the items of 17, 21, 16, and we're told that the mean is 19, but we're missing one of the items, and we have to be able to find that missing item. I always like to break this up into 3 steps. First, we find what we have. And what we have is the 17 plus the 21 plus 16. That's what we have. So I add to find that total. 7 and 6 is 13, 1 is 14, carry the 1. 1 and 1 is 2, and 4 is 2 is 4, plus 1 is 5. So right now we have a total of 54. Then we find what we need. What we need is a mean of 19 for 1, 2, 3, 4 scores. So a mean of 19 for 4 scores means we're going to need a total of 19 times 4, not just 4 is 36, carry the 3. 4 times 1 is 4, is 3 is 7. We're going to need a total of 76 points. Well, we have 54 and we need 76. So the last step is to find the difference. So I have 54, I need 76, so I take my 76, subtract 54. That means that the last score, that missing value of n, is going to be equal to 22. So when we do problems like this, we break it into those 3 steps. We find out what we have, we find out what we need, and then find the difference between those 2. All right, so let's take a look at this next example. It says John made a list of his test scores: 74, 80, 78, 90, 88, and 86. What's the lowest score he can get on his next test to have a mean score of 82? Well, we want to do those same steps. What do we have? Well, we have 74 plus 80 plus 78 plus 90 plus 88 plus 86. That's what we have. So we have to find that total. Let's see, 74 plus 80 plus 78 plus 90 plus 88 plus 86. We have a total of 496. Right? That's what we have. What we need is going to be to have a mean of 82 for how many test scores? 1, 2, 3, 4, 5, 6. And the next test score, so that would be 7. So we have a mean of 82 for 7 scores. We're going to need a total of how much? 7 times 2 is 14, carry the 1. 7 times 8 is 56, and 1 is 57. So we need 574. We have 496. We need 574. So the last step is to find the difference. Right? So we subtract those two numbers, and we wind up with 78. So he would need a 78 on his last test score to have a mean of 82 for the 7 scores. Okay? Here's another example. The number of minutes Marielle spent talking on her cell phone each month for the past 5 months were 494 minutes, 502 minutes, 486 minutes, 690 minutes, and 478 minutes. Suppose the mean for the 6 months was 532 minutes. How many minutes did she talk on her cell phone during the 6th month? We want to use that same process, starting with what we have. So we have 494, 502, 486, 690, and 478. That's what we have. We find the total. 4 and 2 is 6, and 6 is 12. 12 and 18 is 20. 0 carry the 2. 2 and 9 is 11. 11 and 9 is 20. 8 and 7 is 15, so that's 35. Carry the 3. 3 and 4 is 7, and 5 is 12. 12 and 10 is 22, and 4 is 26. So we have 2,650 points. What we need, well, if the mean for 6 months was 532, we need a total number of minutes of 532 times 6. 6 times 2 is 12, 2 carry the 1, 6 times 3 is 18, 1 is 19. Carry the 1, 6 times 5 is 30, and 1 is 31. So we have 2,650 minutes. We need 3,192 minutes if the mean for 6 months was 532 minutes. We need to find the difference. All right. So I find the difference by subtracting the 3,192 and the 2,650. All right. That's going to give me 2, 4, it's 2, and 11. That's 5. So 542 minutes must have been the amount of time that they talked for that last month. All right? Now the last problem we're going to do, we see the information given to us in a table. It says the table shows the greatest depths of 4 of the 5 oceans in the world. If the average greatest depth is 8 and 94 thousandths kilometers, what is the greatest depth of the Southern Ocean? Right? We still want to do this problem the same way we were doing our other problems, breaking them into what we have. Now what we have is the total of these 4 numbers. So we have 10.992 plus 9.22 plus 7.46 plus 5.63. All right, so we have a total of 33.23. We need, if we have a mean of 8.094 for 5 oceans, all right, let's find that. 8.094 times 5 is going to be 40.47. That's what we need. Last step, find the difference. All right, so to find the difference, we just subtract those two numbers, 40.47 minus the 33.23. All right, and that's going to be, that's a 4, that's a 2, it's a decimal point, and that's 3, that's 10, 7. So the southern ocean must be 7.24, and those are kilometers. All right, so that's the end of the lesson. I hope that was helpful for you, and see you later.